Hello, we are InnoMinds. We have prepared an end-to-end telemedicine solution for 9 types of fatal skin diseases. Our approach is multi-layered based. Let me take you through this life cycle of this process. In the process cycle of a project, the first layer comes up to be the user interface. We have created an incredibly easy user interface using HTML, CSS, and JavaScript. The data fetched from this web application is then sent into the data preprocessing functions. This pre-processed data of images is then sent into our CNN model. Our model is based on transfer learning of density 1-to-1 and some custom layers added over it. Our model is trained on dataset of ISIC, which contains about 25,000 different images of 9 different skin diseases which are termed to be fatal. We do not stop here. We promised an end-to-end telemedicine solution, so we are going to provide it. Firstly, we depict the type of disease that the user has uploaded. We give them a brief about the disease and also some precautionary measures. Secondly, we take the access of the live location of the user and plot nearest hospitals and dermatologists on a map on the same web application. We do this by using overpy, leaflet.js, and Folium. We also, with user's choice, provide this information via email. We send them information of nearest hospitals, dermatologists, and some contact details of nearest independent doctors. Let's go over the architecture of DenseNet 1-to-1. DenseNet 1-to-1 is a neural network with 120 layers in it. It has 4 average pooling layers. There are some specialties of DenseNet 1-to-1. Let me name some for you. Firstly, DenseNet allows us to feed the weights of each layer to its subsequent layers, which means a feature that is learned at an early stage, or let's say at the first stage, can be utilized and can be fed on to the most extremist layer in the architecture of the network, which allows us to expand the boundaries and get a very detailed and precise detection. Secondly, it helps us solving the problem of vanishing gradient. It allows us to minimize the gradient in its curve and solve the problem. This is the model of DenseNet 1-to-1.
So after training our CNN model, we saved the model and its weights into a .h5 file. Then we load it into our Flask app. The model is then used to generate inference based on the skin disease input given by the user. The input is first fetched and pre-processed and then fed into the model, which in turn generates an inference which is used to give the disease name and the disease description to the user. Here is the website wherein the user can get their skin disease detected in 3 easy steps. The user chooses a file of the infected skin, then uploads it. It is then fed into the model, which gives the disease name with the corresponding disease description, which can come in handy to the user, and some steps that the user can take. Furthermore, if the user wants to consult a dermatologist, if the user gives us the permission to detect their location, based on their latitude and longitude, we find the nearest doctors and suggest them to the user, as shown here. Furthermore, if the user wants to get all this information onto their email, they can simply enter their email here and click on Get Details. The user will then be able to get all these details sent on their email. Some email is then sent to the user as shown here.
This whole telemedicine ecosystem has been created and introduced by InnoMinds. Technology is the power of this age, and with great powers comes great responsibilities. We at InnoMinds are dedicated to use this great power to its full extent to solve this problem. This is our motto too. Thank you very much. This was InnoMinds for you.